Today is the final lesson for 1.3.1. It is graphing and interpreting linear equations in context. And our objective is students will be able to create and graph linear equations. So let's start this out with our vocabulary words. We have 3 terms today. Our first term is independent variable. And the independent variable is labeled on the x-axis. So when we are graphing and labeling our axes, our independent variable is going to go on that horizontal x-axis. And the independent variable is the quantity that changes based on values chosen. What that means is that this number is only going to change if you decide you want to use a different number. So our independent variable is our x. An example of that would be like time. As you can't really change time, but you can choose how much time you want to go by and then see what the effect of that would be. So we have our independent variable, then we're going to have the opposite, the dependent variable. So there's independent variable and then the opposite, the dependent variable. Our dependent variable is labeled on the y-axis or that vertical axis. And it is the quantity that is based on the input values of the independent variable. So we have our independent or our x, and you plug it into your equation and the outcome is the dependent or the y. Our final term that we're going to look at is rate of change. And rate of change is something that you should be familiar with by now. Rate of change is basically your slope. We call it rate of change when we're talking about something in context. So it's the change of y, or change of your dependent variable, divided by the change of x, or change of the independent. So an example of rate of change, or an example of slope in context, is miles per hour, how fast you're going. In that case, your dependent would be miles and your independent would be hour. So we have miles per hour. Another example is something like how much you make at work, the dollars per hour. That's the rate that you're paid. Those are examples of rate of change, or how quickly something is changing. Now that we have those 3 terms, independent variable, dependent variable, and rate of change, let's go ahead and look at a linear equation in context and see if we can come up with the answer. So we are going to create a linear equation and solve and answer a question to that linear equation in context. So as always, when we are solving something in context, the first step is to actually go through and read the problem. So please follow along with me while I read and copy this down in your notes. A local convenience store owner spent $10 on pencils to resell at the store. What is the equation of the store's revenue if each pencil sells for 50 cents? Graph the equation. So, step 1, I read the problem. Step 2, I am going to identify the independent and dependent variable. So, we said that the independent variable is the quantity that changes based on the values chosen. Well, I have 2 variables here. My first variable is the number of pencils sold. And my second variable here is the revenue, or how much money I've made. So my independent variable is something that basically you get to choose it. Dependent is going to change based on what you chose for the independent, or what quantity you chose to substitute. So between pencils and revenue, I can't really choose the revenue. The revenue is going to depend on how many pencils are sold. So because it depends on the pencils, I know pencils are independent, and my store's revenue is going to depend on how many pencils are sold. So we have our independent and dependent variable. My next step is to determine the slope, or the rate of change. Remember that slope is represented by the variable m in slope-intercept form, y equals mx plus b. So when I read through my problem, I see that I'm selling a pencil for 50 cents each. So the revenue, or the dollar amount, 50 cents for each pencil sold, is my rate, or the slope. So let's say the rate of change equals 50 cents per pencil. And another way we could write that is slope equals 0.5. Now, I'm used to working with slope as a fraction, not a decimal. So off here to the side, let's just quickly go through how we can convert a decimal to a fraction. 0.5 is 5/10. So I'm going to take a 5 and put it over 10, because that 5 falls in the tenths place. If we simplify the fraction 5 over 10, it's 1/2. So we could say that our slope is 0.5, or we could say that slope equals 1/2. So our rise would be 1 and our run is 2. Okay, so I found my independent variable, pencils, found my dependent variable, which was the store's revenue, and then I found my rate of change, or found my slope, to be 1/2. Now let's go on to step 4, which is to determine the y-intercept. And if you remember from yesterday, we said that the y-intercept is kind of the same thing as the starting point. And we represent that starting point with the variable b. So, what is my starting point in this situation? Well, if you go through and you read again, you will see that we started by spending $10. Well, if you think about spending money, when you're spending money, you're losing it. So I'm going to say that b equals -10. So I found my starting point at b equals -10. My slope is 1/2. My dependent variable is the store's revenue, and my independent is the number of pencils sold. I'm ready to move on to my 5th step, which is to substitute m and b into y-intercept, or slope-intercept form. So into y equals mx plus b. Let's move to a new page to do that, and I'm going to pull up a graph here. So our m equals 1/2, b equals -10, so y equals m, which is 1/2, x plus b. So instead of plus b or plus 10, I'm going to do -10 since b is negative. I've substituted my values in order to get this equation. Now, last step, or sixth step, not quite the last yet, is to label our axis. So we know our independent axis, your x-axis, is pencils, and we know the y-axis, or the dependent, right here is the store's revenue. So x is going to be pencils, y will be store's revenue. So I've labeled my x-axis as number of pencils, my y-axis is the store's revenue, and I am going to do my scale by ones. So -1, -2, -3, -4, and so on. Over here we'll go by 1, 2, 3, so on, and then going up we'll go by 1, 2, 3, 4. I want you to label more than that. It's kind of difficult to label on this, so that's all I'm going to do right now. So let's go back and look at our steps to see what our final step is. We have read the problem, we've identified the independent and the dependent, we found our slope or rate of change, we found the y-intercept or the starting point, we took that slope and y-intercept and we substituted them into y equals mx plus b, we labeled our axes, and finally we are going to graph that equation that we got in step number 5. So to graph, the first thing I need to plot is my y-intercept, which is at -10, down here. And then my slope is 1/2, so I go up 1 over 2, up 1 over 2, up 1 over 2. And you can continue going up 1 and over 2. You have to do at least 3 points for me, though. Now, notice when I drew my line that I did not go past right here. That is because, I mean, really I shouldn't have even drawn the x-axis right here, because this is the number of pencils we're selling. We can't go back into the negative number of pencils. So we don't really need this section of the axis or of the coordinate plane. We just need our negative, you know, when we haven't made back our money yet, and then our positive of where we're making back money. We're going to do one more of these. If you need to, feel free to go back and watch this one again. You can watch the next one a couple times as well. All right, our second example is a taxi company charges $2.50 per ride plus $2 for every mile driven. Write and graph the equation that models this scenario. So step number 1 was for me to read the example, or read the question. Step number 2, I need to identify my dependent and my independent variables. So independent variable is the variable that changes based on values chosen. So I have two things here. I have the cost of the ride and the miles driven. Well, the cost of the ride depends on how far I go. So since it depends on how far I go, that is going to be the dependent. And the miles driven, or how far we go, is what you can decide and what is going to determine that dependent variable. Sometimes it's easier to pick out the dependent variable first because you can pick out, well, cost of ride is going to depend on something else. Cost of ride depends, so that's the dependent. What it depends on is the independent. All right, let's move on to step 3, which is for me to pick out my rate of change. So look at the question above, and we see that you are charged $2 for every mile driven. If you ever see something that says like per or each, that's not guaranteed that it's your rate of change, but it's a pretty good hint that it is the rate of change. So my rate of change is $2 for every mile. And let's take that and change it to slope. that would be 2 over 1, or just simply 2. Step 4, we need to identify our starting point. And if you look above, it tells us that the company charges $2.50 per ride. So when you get in the car, it doesn't matter if you're going to go 1 mile or 100 miles. You still have to pay $2.50 just to get in the car. So our starting point, or our y-intercept, is going to be 2.5 or 2.50. Step 5 is for me to substitute my slope and y-intercept into slope-intercept form. So y equals m, which is 2, x plus b, which is 2.5. Y equals 2x plus 2.5. Step 6 is for me to label my axes. So let's go to a new graph. And I am going to label my x-axis as my independent variable, which is the number of miles. And my y-axis is going to get labeled as my dependent, which is the cost of the ride. Now sometimes you might need to skip. Let's say our starting point is 100, but we go up by 2 every time. It would be kind of ridiculous to go 2, 4, 6, 8, 10, 12, 14, all the way up to 100 and not even start until 100. So sometimes if that were to happen, you would draw a little zigzag line there to show that there's a break. We don't need to do the zigzag right now because we are going to just start at 250. Y equals 2x plus 250, or 2.5. So I go up 2.5, and my slope is up to 2 over 1. 2 over 1. If you are ever graphing and you have a decimal like I do now, make sure you go up the full unit. Don't just go up to the next line or to the next point. You have to move the full unit. So there is approximately our line. Notice that I didn't go back into the negative for x. I didn't go down into the negative for y because I can't go backwards. I can't take my miles back. I also can't, the taxi's not going to pay me. I'm going to be paying. So it's going to be up, going positive. Okay, so those were our 2 examples. Go back and watch another one if you need to. We will do another example in class tomorrow. And don't forget to take your quiz on lesson 1.3.1, part 3. Or if you're in honors, don't forget to take your quiz on lesson 1.3.1 and for those 3 videos that you just watched.